Why can you switch off one light in your house without killing the rest? Why does a fuse melt to save you? And why is the wire inside a heater different from the wire feeding it? It all comes down to how resistors combine and what current does as it flows. Let's connect some resistors. First, resistors in series, joined end to end in a single line. There's only one path, so the same current flows through every resistor. The total resistance is just the sum. R series equals R1 plus R2 plus R3, and so on. Adding resistors in series always increases the total resistance, and the voltage from the cell splits up across them. Series has a big drawback for everyday use. Because there's only one path, if a single component fails or switches off, the whole circuit breaks and everything goes dark. Like the old string of fairy lights where one dead bulb killed them all. And every device is stuck sharing the same current. Not what you want at home. Now resistors in parallel, each connected across the same 2 points, giving several separate paths. Here, every resistor gets the same full voltage, and the current splits among the branches. The total is found from 1 over R parallel equals 1 over R1 plus 1 over R2, and so on. A neat consequence, the combined resistance is always less than the smallest individual resistor because you've opened up more paths for current. That's exactly why your home wiring is parallel. Every appliance gets the full 220 volts it needs. Each can be switched on or off independently without affecting the others, and the total resistance stays low so enough current is available. Series for adding up resistance, parallel for independent full voltage devices. Now, what does the current do as it pushes through a resistance? It heats it up. This is the heating effect, and Joule's law gives the heat produced. H equals I squared times R times T. So the heat depends on the current squared, the resistance, and the time. Double the current and the heat quadruples. That's why current matters so much. This heating is sometimes the whole point, sometimes a danger. We want it in a heater or toaster. The element is nichrome, high resistance, so it glows hot. A bulb's filament is tungsten, which gets white hot and gives light. But we guard against it with a fuse, a thin wire that melts if the current gets dangerously high, breaking the circuit before anything catches fire. How fast is electrical energy being used? That's the power. Electric power P equals voltage times current, V times I. Using Ohm's law, you can rewrite it 2 more ways. I squared times R or V squared over R, whichever fits what you're given. The unit of power is the watt. 1 watt is 1 joule per second. Your electricity bill, though, isn't in joules. It's in kilowatt-hours. 1 kilowatt-hour, called 1 unit, is the energy used by a 1 kilowatt appliance running for 1 hour. So a 1,000-watt iron used for 2 hours uses 2 units. Energy equals power times time. That's what you pay for. Let's compute. A bulb is rated 60 watts on a 220-volt supply. The current it draws is power over voltage, 60 over 220, about 0.27 amperes, and its resistance is V squared over P, 220 squared over 60, which is about 807 ohms. 3 formulas, 1 bulb. Your turn. The question's on screen. Pause if you like, but try it first. 10 seconds. Go. Two 6-ohm resistors in parallel. 1 over R equals 1 over 6 plus 1 over 6, which is 2 over 6, or 1 over 3. So R is 3 ohms, half of 6, and less than either resistor, just as parallel always gives. The answer is 3 ohms. Option A. And that completes electricity. Series adds resistance. Parallel keeps devices independent. Current heats a resistor by I squared RT, and power is V times I. Free notes with practice questions are in the description. Subscribe for the next chapter, Magnetic Effects of Current. This is Clarix. Keep going.